So because I'm not ready yet.
Gotcha.
Yeah. What about you?
Yeah, I mean, I haven't done it 30 or 40 times. Maybe I've done it like 10 times in total, but yeah, I'm definitely using it to prepare. I have a few interviews. I have Facebook this upcoming week, Palantir. I think that's it, actually. I finished all the other ones. Haven't heard back, though, from anyone.
Good
So,
luck.
yeah, thanks, man.
Are you based in US or in Canada or in
I'm
anywhere
in,
else?
I'm in US. I'm in New York right now. How about you?
Oh, in New York. Yeah, I'm actually I'm actually in Canada.
Oh, which part?
Well, actually in Alberta. I'm not sure if you know Alberta.
Oh,
But I'm
you're,
reporting to a yeah, I'm reporting to a company in Toronto.
you work for companies. What? Sorry.
Oh, I'm working for a company in Toronto.
Gotcha.
Yeah.
Oh, Alberta's.
Anyway,
Oh, yeah. Of course, I know Alberta. This is. Oh, it's so
you've been here
beautiful.
before?
No, I really wish I had. Um, it's really beautiful. Like there's a lot of nature.
Yeah, Banff and National Park, and yeah, it's really beautiful.
All right. Well,
Let's get started after. Yeah, I
yeah.
think
Let's get
this is
started.
yeah, I think this is your part.
All right. Sounds good. I'll just read this over very quickly.
Hmm.
Okay, so we have an array of characters that consists of um, sequences of characters separated by space characters. Each space delimited sequence of characters defines a word. Okay, very intuitive. Implement a function reverse words that reverses the order of the words in the most efficient way. Okay, interesting. So perfect makes practice, and we want to make it practice makes perfect. Interesting. Okay, there's a few. Can you hear me? Sorry, I just cut off.
Yeah, I think this is some networking problem. I can hear you now.
Okay, nice. So there's a few um, approaches here. I think I'm trying to think if there's. I don't think there's a way to avoid at least a linear runtime just because we need to find the spaces and they could be anywhere. So we're gonna have to iterate through the entire string, or the entire all the characters in the array. And I guess initially we could just split. If we just split the array, um, we could get a new array with instead of characters, we could have the words in the array. So it's just I'm just going to copy the input here. So this is our input. And if we somehow turn this into like this, I'm just playing around with to see if this is like a good approach. But this is the first thing that comes to my mind. Let's say we instead made it splitting it into perfect, or oh, this is the output actually. Oh no, this is the input. Okay, cool. Makes practice, right? And then from here, it's pretty intuitive. You just iterate backwards, or you could just return the reverse of this. Um, I don't remember the exact method in Python, but I think it's something like that. Um, is it this easy?
No, no. I wish it was. Because you're going for Facebook. Well, I'm gonna. Well, a few. I mean, actually, let's talk about this method first. I think this is a very good starting point.
Mhm.
And also I won't gonna make it easy for you because again you go into Facebook.
Yeah.
I want to give you a little bit more practice. So
Okay.
my first thing first, this is very good starting point. I must say this is the approach that I came up with. But there are some problems in here. For example, we are losing some empty space, right? Because we basically pushing all the word, right? And then
Right.
when it reverse it, and then at the end is actually is returning this array of each actual word, not
Oh yeah, yeah, yeah.
letters. Yeah. So a few things that we have to. I mean, it's but if a few more lines of code, it's not that hard to convert it back to letters, right? I mean, I know that you can do that, and
Hmm.
also we are missing some spacing in between, and also I know that you can do that. It's not that difficult,
Hmm.
but um, you are utilizing an external space which is array two,
Right.
right? And I yeah, I can tell you that, and you are right that the best time complexity gonna be big over n. There's
Hmm.
no more way we can do better than that. That's the best we can do.
Hmm.
But what I can do is what I can tell you is that you can do better than BON for space. You can do BO1. You can do it like
Okay.
in place.
Okay. Interesting. Yeah, I think I'm gonna focus on that solution just because I think the other solution is pretty easy. I mean, yeah, it's yeah, like you said, it's not hard to turn this into characters array and then return the reverse. So I'm gonna focus on in place. All right, how do we do this in place? Let's see. Hmm. Presumably, we want to keep track of. Okay, well, at least we can iterate through the array. We might have to do more than one pass through the array.
Mm-hmm. Good.
Maybe if we iterate through the array once the first time, we'll just record in maybe we'll have a few variables. Actually, that is not potentially. I was thinking if we keep track of where the spaces are.
Yeah.
Um, but I wouldn't want that to become big O of n space in the event that the entire array is spaces. Uh,
Well, I think I would encourage you to keep thinking along that direction because um, well, the spacing. But actually, let me walk you through something. I think you are in the in the right direction. I don't want you to go to the other way. So when you scan through this guy, right, and when you hit the space, right, and then you can do something about it, and then you keep going until you see the next space, and then you can do something about it again, right? So it's
right.
not gonna take you big O N. I mean, you can do something about it, and then you're done, and then you can move forward,
Hmm.
and then do some yeah,
Interesting.
and do the similar thing again, right?
Gotcha. Okay. All right. So yeah, if we were just doing this by hand, I would intuitively just iterate through perfect, and then when I reach this space, I would realize, okay, like we've just reached the end of a word, and we know the start index and the end index of that word. This is where it starts, this is where it ends, and this is where it starts. Um, and we
Yeah.
know that this word that we just encountered, we want it to be at the very end of the array ultimately. Um,
Yes.
okay, so at this point, we know we have the yeah, we just have. I guess we could have like if we have like pointers, um, LR, something like that. Then we
Mm-hmm.
know L equals 0, R equals 6. Um, this is where the first word occurs, and
Yeah.
we know that. we know that this word should be at the very end of the array, and it's going to occupy 7 indices.
Okay.
So we would have to shift. Yeah, ultimately, I think we're going to need a temp variable. We need a temp variable because otherwise we can't. At the very least, we need a temp variable because otherwise we can't do anything.
Yeah. Yeah. You need a temp variable to save these indexes. Yes, I agree with you.
Right. I'm just going to record all the information I know for now. Maybe it'll be redundant later, but let's just place perfect in this variable. Right. Well, actually, it doesn't. I mean, it doesn't really matter because we can access it through here, but whatever. So the thing is, when we proceed onto makes, we're gonna want to record the information for makes, but we don't want. We want to do something about this now rather than later, so that we can use these variables instead of just having an array which stores each of these variables. Because that would lead back to the linear space complexity. So what can we do
Okay.
about this now rather than later? I suppose we could shift. If we shift everything back, maybe, since we already know, like, this is where the first word was. Well, actually, we want to reverse it, right? So if reversing means that we have their name is David, and we're returning David is name. Right, so it's it kind of, yeah, it reflects across the middle pretty much. How do we do this?
You're making a lot of good progress, but the thing is, this good progress. Don't toss it. Put it in your brain because you're gonna need it for the next step. I mean the second step. Okay. You definitely making a lot of good progress in here, but you're missing one and also important step at the beginning. So let me give you a little hint to move
Mm-hmm.
this rolling.
Mm-hmm.
I think if you give it to you, then you'll be aha. That's
All right.
that's the way to go. Okay, so uh, and to be quite frank, I couldn't solve this problem without. I mean, with the big old one, um, space complexity. When I was solving it, I came up with the same solution that you came up at the beginning. So,
Mm-hmm.
but again, we go to Facebook. So
Right.
now let's say I think this is a bit too long. I'm gonna have a shorter one, just for an example, for our discussion. Let's say if the string that we given is A, B, C, space, and D and E. Okay,
Mm-hmm.
so the first thing that is done by the official solution is looks like something like this.
Right.
Does it make sense? So you're basically reversing the whole thing right off the bat.
Like, you're saying, how do we get from here to here?
No, no, no. I know that you can do that, but this is the first step. I'm telling you, you can use this one to build off your solution toward the end. Does it make sense?
Um.
So yeah, but no. This is the okay. So okay, I should say even. So this is the end result, right? So let's say this is the
Right.
input, right? This is the input, and step one, I got it hard because step one. Step one equals something like this, and this is
Mhm.
where you are missing, I think. And the output that we're looking for is obviously something looks like this, right? Right. So this is the hint I'm giving to you right now.
Oh, I see, I see, I see, I see.
Yeah, that's why I was like, oh, if I give it to you, and then you'll be like, oh,
I see. Okay.
and then you can
Yeah.
apply
So
what you just, yeah, you just discussed with me.
okay. Oh my. Yeah. Okay. Okay. Yeah. That makes it simpler because um right. We want to reverse it. Um. Yeah. If we reverse this entire thing, um, like we'll essentially have the let's say like the shape, like the form of the letters. They'll be reversed, but they'll be at the correct place anyway. So we don't have to worry about shifting or anything like that. Um, we can just in one linear time pass through the input, we can make it reversed, and then we can iterate through it again and simply turn all the words, like reverse them once again, so that they actually can be read from left to right.
Yeah,
Right?
exactly. Basically, you are reversing the whole thing, and then you scan through which one is the word, and then use exactly the same approach that you described. You were so close. That's why I give you a little more
Okay.
hint in the beginning. Yeah, if you were just missing the first step,
Yeah,
and
yeah,
then
yeah.
you're
Okay.
reversing the word. Yeah.
Okay, cool. Yeah. So let's the first thing that we want to do is if we do something like r dot reverse, um, that'll take care of that. I guess we can just use let's just use this input for now because it's easier. Um, and then we can just this is input dot reverse this, um, and then from here we will iterate through the entire thing. Let's make it a little bit more interesting. Or actually, let's just work with this for now. Um, so we'll iterate through the array. And whenever we encounter a space, that's when the previous word ended. So we'll have like, we'll store a few things. Um, word equals empty. And then, so let's just have like a few pointers here. We'll have left here, and then we'll have right. And then we want to increase right until we find the space. So at this point, we find the space, which means that r minus 1 and L is the range of is the range of the previous word we encountered, which means we want to reverse it. So I guess we can iterate at that point, like for every how do we yeah we have to iteratively reverse that word. Um, which yeah just involves switching L and R until you get to the middle, right? So yeah, that would just be a loop. We could come up with a loop. Um, I'll write it later, but like at this point, like we traverse these two, this loop, And then we actually want to make left whatever is after the space, and right to just always be one after left. And then we'll once again loop until we encounter a space. We'll increase R until we find a space, or we reach the end of the array. So we increase R, we increase R. We're at the end, which means this is the word that we want. And then we once again iteratively like move the pointers closer to each other until reversing each one with the other, and that should take care of it. How does that sound?
Yep, sounds good to me. Let's code it up.
Okay. Okay, so we'll just here. Right. So first thing that we want is we'll iterate. So L will range from the beginning until. Well, the first thing that we want to do is. Is this how you do it? I don't remember.
I think you can do this, and or you can do it like if in Python you can do like do something like this, right? Yeah, I think this will work. Also, you can do something looks like oops, what did I do? Looks like do something like this. So
Oh,
either
this
way,
reverses it?
right? Yeah, this one will reverse it, or you can do this one as well. I think this one will work as well, but I think this I don't know. I'm not sure. This is my go-to way to reverse the element.
Okay, nice. Yeah, so we reverse it, and then we start iterating. So L is going to go from the beginning, and it's always going to be, we want it to be less than R. So I guess we want it to go at most until here. And R minus 1. And then R will go the whole way, but it'll always be 1. Forgive the noise. It'll always be 1 more than L at the beginning. But this will always. Okay, let's just say R is equal to L plus 1. And while R is less than. So if R, well, the first thing that we want to make sure is that R is within a valid range. And we want to stop. So I'll take care of the bounds after this. But basically, if R is equal to its space, if the index is equal to its space, then we know that we've reached a word, the end of a word, which means we want to reverse everything from L to R. So at this point, what we could do is, let's just see a few examples really quickly. If we just have B and E, it's very simple. We have L and we have R. So we just like swap L and R. And if we have an odd number, E, E, F, and we swap L and R, swap these two, and then when L and R are equal, we just stop. So it actually doesn't make a difference. Um, so basically, whenever L is less than or equal to, whenever L is greater than or equal to R, we just stop. And it should take care of both even and odd cases. Do you agree?
Well, the thing is, I was thinking like, um, the L is keep advancing, so it's keep moving, right? So I was thinking like, can L be staying at the beginning point of the word, and then the R will be the one keep advancing until you hit the empty space,
Right.
and then you will capture that word that you want to
Exactly.
reverse.
So maybe I would use other variables just so we don't mess up the L and R. But I was just referring
Yeah,
to
I
the
was thinking. Yeah, for example, the L pointer right here, right, and then the right pointer keep moving, 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 moving until it hits empty space or the end, right? So and then you can get the the these two. I think you say it really well at the beginning right here, right? You see that L is 0 and R is 6. So you
right.
capture that part. After you capture that part, you know what to do. You just swap the whole thing.
Yeah. Exactly. Yeah. So once we have L equals 0 and R equals 6, I was just referring to like how the swapping would actually, how the flipping of the word would actually take place. Does that make sense?
Well, you can write a separate function that is
Yeah.
taking the L index and also write the R index, and then you capture that part of
Exactly. Yeah.
the yeah, and then you know
Yeah. So we'll keep increasing R until we hit a space. Let's say R equals L plus 1. Um, while R is not equal to space, or R is, so if it's not equal to a space, we want to keep going. But we also want to keep going if, so yeah, while it's not equal to a space, um, we'll just keep increasing R. And when we hit a space, I'll take care of the bounds as well. But when we hit a space, we want to pass L and R to a separate function, which we can call swap, and we'll pass in the array, pass in L, we'll pass in R. Um, and then, so that part is swapped. And then after, after that part is swapped, we want to make L the index of, actually, yeah, I don't know if a for loop is the way to go. Just because we like, okay, so when we get here, R is going to be here, but then we want to make L equal to index 3. Um, so I guess we can say maybe we don't even need this loop in the first place.
yeah, exactly. You don't.
We'll just say L equals 0. This is fine, and then we increase R. Um, once that's done, we reach the word. Let's pass then um, we make L equal to R plus 1, or yeah,
Yep.
R plus 1, and then we make R equal to R plus 1. as always, and then we repeat this. And we stop. Presumably, we're going to have another loop because this is only once. So when we get here, this is where R is. We want to repeat it, and we want to stop. So we'll have while yeah, I guess it'll always be the case that, like, let's say this is where the string ended. If we had an array that looked like this, the array, then we would want to, like, L would actually be out of bounds. So I guess we can check both L and R. Whenever either one of them, oh, if L is out of bounds, we're definitely done. But in this case, L is not out of bounds, but R will go out of bounds. So that's two different situations. In this case, we actually still have a word. In this case, we don't have a word. So while L is, yeah, we'll just say while L is less than like the array, we'll want to repeat this. Then we also want to account for this condition. So while this is the case, we want to increase it. If we hit a space, we want to increase it. Or if we don't hit a, whenever we don't hit a space, we want to increase it. But also, we want to stop increasing. We want to swap when we reach the end of the array. But actually, yeah, this actually would be the end as well. Like if L ever goes, if R ever goes above the array length, like that's the end. Like the next step doesn't matter as well.
Well, yeah, I mean,
Then we would want something here at the end of the loop. Take care of the last part.
yeah, okay, yeah, I think probably you only need an if statement here. Basically, because you're checking each step when you advance the R, right? Basically, when you increase the R, you're going to checking are you hitting or not, right?
Right.
Because
Actually,
this
yeah.
one, yeah. So in this while loop, you keep advancing the R until you hit the empty space, and then you're gonna do something about it, and yeah, and then well, you can place either the R here or at the end. I mean, it's your style. And then when you hit something, you're gonna do the swapping. Also, you update the L at this point, right? And
Right.
then you also at the same time you can either advance the R over here or over here. Is again it's your style. Um, yeah, and what else? So yeah, so um, when you hit the wall at the end, there's no empty space. So that's the edge case that we have to take care of as well.
Mm-hmm.
So I would suggest this is not the official solution how it was done, but the way that I would do it would be at the end, for example in here, right, line 33. So A, B, and C, and D, and E. I think this make my life a little bit easier. Would be at the end, I'm gonna concatenate empty space.
Yeah,
So I
that's good.
yeah yeah this is like a bit like a clever way to do it. I mean you can make the code a bit fancier, but I think this is make my life a bit easier.
Yeah,
Then
that's
when
the
I
way.
hit the empty space, yeah, when I hit the empty space, you can swap the one that before, and you have the left and right point. That's exactly what you need. Also, you keep track of. So when you hit the empty space, you're gonna yeah.
Yeah.
I think
Yeah.
I think
Honestly.
you
Yeah. That's way better, honestly. Um. So yeah. We increase R, and then at the very end, we just want to return R. So whenever we hit an empty space, we swap them. Well, actually, this should be equals, right? If it's
yeah
an empty space, we
exactly
swap them, and then we increase our pointers. I guess the only one of the only things left is to create the swap. Takes R, L, R. Um, so while L is less than R, we want to basically say R L is equal to the temp is equal to R L. R L is equal to R R R is equal to temp. That's it, right? And
yeah
then we want to
exactly.
increase, yeah, we want to increase equals one, one. That's it.
Yeah. So
How does that?
this part is just yeah, it's just swapping the whole thing.
Mm-hmm.
I think in Python, I think there's maybe one more way to do this. I mean, this one definitely can work, and also very clean code as well. And you might come across people will do this one as well. Again, this is actually what how it's done by the official solution. But if I was to do it, I would probably do something like this. With the help of Python, we can do something like this directly.
Oh wow, didn't know that. That's nice.
And
Oh yeah,
yeah,
of course.
and then you can advance also decrement the index for L and R respectively.
Yeah.
But I do agree with you. This one is a lot more cleaner to see actually. Yeah, it really depends on your style and also your preference. It's just doing the exact same thing. But if you
Okay.
want to, if I was to impress an interviewer, probably I would do something like this.
Really? Okay. Yeah. Good to
Yeah, but
know.
I
Thank
mean
you.
again, again, it really depends on personal style and preference.
Okay. Sounds good. So is this looking good to you?
Yeah, looks good to me. Yeah. Um, I really like it that so some feedback I have for you.
Hmm.
I really like it that you talk out loud, that you so I can follow your thought.
Yeah.
I know this is very core principle for coding interview. Sometimes people just mumbling or not. I mean, mumbling is not too bad. I mean, sometimes people just stop talking when they're thinking about
Hmm.
it. And I was like try to follow their thought. I really like it that uh, where you get stuck because I when you say it out loud and I know that where you get stuck and where you need the help. So I really like it that you keep talking while you're thinking, and also I really like it that this at the beginning you come up with the left pointer and the right pointer,
Hmm.
and then you know where the words should. I mean the indexes should stay,
Hmm.
and then you were just stuck where what you do with it, right? And then I gave you a little bit push, and then you were like, oh yes, um, and definitely this problem is not that easy. I couldn't come up with a big old one solution at the beginning, and um, yeah. So yeah, that's my feedback to you.
All right.
Yeah.
Thank you so much. Really appreciate it. Um, I know we went a little bit. I don't know how long these things are supposed to be, but um, I'm happy to start yours whenever.
Okay. Let's get started then.
Okay, sounds good.
By the way, when is your interview with Facebook?
My interview with Facebook is this Friday.
On site?
No, it's not. It's online. I mean, by on site, you mean like final or like in person?
Yeah, yeah. Final. I mean, I know that this all the interviews are going online now.
Yeah,
So on site, I mean, okay,
yeah.
final
It's
round.
it's
Okay,
it's the
good.
final it's the final round. Yeah. So
Wow,
hopefully,
good luck.
thank
I'm
you.
excited when I hear that you're going for interview.
Yeah, 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 yeah. Um, but yeah. So this problem is like,
Because I just reached out to a Facebook recruiter a few days ago, and then they are finding a team for me. I'm not sure if they can ever find a team for me. I don't know, but I'm still waiting. I also really wanted to work for Facebook as well. Um,
yeah. I
so
think,
I
to
was
be honest,
excited.
there are.
Hmm.
I'm not too. To be completely honest with you, I'm not like, of all the places I'm interviewing, it's like one of the ones that I don't really care if they say no. You know, because it's like, with everything that's happening, I don't see a happy long term there. You know,
Okay, why?
just because of all the privacy issues. All of these. It's like, I fear, because since a lot of the pay is in stock, and to be honest, I can't look at Facebook as a company and like have confidence in it like for like 5, 10 years from now. So I wouldn't want my stock compensation to go to zero.
Okay, I hear you. So yeah, I mean myself, I haven't not used Facebook for a very long time.
Hmm.
Uh, yeah, I mean the thing that I'm looking at Facebook is not definitely not not only the web page. I
Yeah.
actually looking some product like Tensor PyTorch, like PyTorch is
Mhm.
by Facebook. Also React is by Facebook, right? I'm looking those
Right, right, right.
yeah, those surrounding product is not.
Yeah, that's
Yeah,
no.
yeah.
That part is
I know
great.
that. Yeah, I know that Facebook, like the website itself, is going down, and I haven't. I also my friend are not using Facebook no more.
Hmm.
Uh, but I do get what you're saying. Yeah.
Yeah, but there's definitely, like, it depends on the team. I think, because if I landed maybe something on the React team, or if it was even Oculus, I think Oculus is very cool, just like virtual
What is
reality.
Ocular?
Oculus, like the virtual
Okay.
reality thing.
Wow. Okay. Yeah. Okay.
I
I
think
don't
that'll
know
be
about
awesome.
that. Okay. Yeah. You see, yeah, that's something that I was looking forward to.
Yeah.
Yeah. Anyway, let's get started. Um, I got a array for now. It's okay 9:45. So hopefully I can solve with 30 minutes. So array quadruplet. Okay. Wire function finds four numbers. Okay, so this is basically like a four sum problem.
Exactly. I'm got. Have you done foursome on League Code, or?
No, unfortunately
Okay.
not.
Okay. Good. Good. Because if
I've
you
done
had,
two.
then it would be very easy.
I've done like two sum and three sums,
Hmm.
and I think okay.
It's very straight. I mean, if you've done those, it's very similar.
Fair enough. Fair enough. Well, unfortunately, I haven't done. Well, I think, but I need to only return like a one answer, right? It could be multiple different answers available
Yeah.
in the.
The first one you
So I
find.
okay. The first one I found. Okay, and can I reuse some of the elements in the array, or have this become unique?
Unique. They need to be different elements.
Okay, okay, fair enough. So let's say if I find like a four in array, I cannot use it five times. If I take
I
this
mean,
example.
if there are multiple fours in different indices, then you can. But if it's the same index, you can't.
Okay, okay, fair enough, fair enough. Okay, I need to return it in this particular order. So that thing kind of tells me that I have to sort it in somehow.
Hmm.
Uh, and already the sorting takes big O and log n. Um,
Hmm.
let me think. So let's sort it. I'm gonna have a small example that I can work with by just by hand. So
Mhm.
let's say if I'm given a list looks like I don't know 2, 1, 3, 5, and 5 again.
Mhm.
The S I'm looking for is let's say 6 for instance. So if I sort it, I would get something like 1, 2, 3, 5, 5. Okay,
Mhm.
so okay, what do I do next? I'm gonna do so I have the number 1. So when I scan through this number, I know that the remaining that I need will be 5. No, but I need exactly 4 numbers, right? Okay, yeah,
Yes, you need exactly four
that's
numbers.
okay. That's the challenge. So I can either scan through something like this. If I do that, is 1 plus 2 to 3, 3 plus 3 is 6, 6 plus 5 is 11. So I'm over it. So I'm over it. Uh, let me think. 2, so 1 plus 2. Yeah,
Yeah.
so this is not the best example. I couldn't find a solution for this one. Maybe it's one in here. Uh, yeah, so 1 plus 1, 2, 2 plus 2 is 4, and also a 2. Yeah, so for this one, I can find solution, right? 1 plus 2 is 3, 3 plus 3, hang on, 1 plus 2 is 3.
Yeah.
Yeah, so this one will work. Yeah, if I sort it, yeah, so it's gonna look, something looks like this. So 1 plus 1, okay, yeah. So unfortunately, this is not a backset. Let's say if I put some zeros at the beginning
Mhm.
and also negative 1 at the beginning. So
Mhm.
in that case, I would have something like negative 1, also 0.
Mhm.
Okay, so the first pass I have in here. So that's the first 4 numbers. What I'm gonna get is, let's say it's gonna be 1. 1 is too small. It's smaller than 6.
Right.
And maybe I can slide the window to here. So that's the next larger sum, which is 4.
Right.
4 is still 4 is still smaller than 6. And then what I'm gonna do is slide to here. And then 1 plus 1 is 2, 2 plus 2 is 4, 4 plus, and I'm done.
The problem is if you do the sliding window, you're not gonna be exploring all the possible. You might miss it. You know what I mean? Because let's say you have it's sorted, and then this is the window that you're looking at. You could potentially have like the answer right in front of you if you did like kept -1, and then, for example, just as an example, looked at these three, right? Skipping the zero, but then these are the next three numbers, like 1, 1, and 2. So if you do that, you're not actually looking. I guess, how do I put this? The reason you sort it is because you want to take advantage of the fact that you can look at it in increasing order and say like increment the window that you're looking at like to just like one greater, like the next greatest combination, right? But
Yeah, okay, I hear you.
by sliding the
Okay.
window, the entire window, you're skipping some of the next largest. Does that make sense?
But by sliding the window, I was thinking, yeah, I do get your, what do you mean? I need to just move out the smallest guy out of the
Yes.
window.
You need to find
But if
what's the next if the current combination is too small, how do we find the next smallest that's big, that's still bigger, that like the one that is immediately um, greater than what you currently have?
Well,
If it's an
yeah. I mean, this is yeah. I'm trying to get uh trying to try to get, let's say if negative 1, 0, and 1, 1, then the smallest one within this one will be the one on the left, which is negative 1, right? Yeah, because it's
right.
sorted, right? So if
Yeah,
I've so the remaining will be 0 and 1, 1.
yeah. I guess what I was trying to say is, like, let's say right now this is what you're looking at, right? You're looking at this, um, like the first four indices of the array, and you realize, okay, this is not six. This the sum is not six. Um, how do I find the next candidate that in such a way that I'm exploring it? I'm taking advantage of the fact that the array is sorted, which means that the next combination of four indices that I look at should be the one that is immediately larger than the one I'm currently looking at, but I'm not skipping anything, because if I slide the window here, I'm going to be skipping some. So basically, the way to find the next. So let's say you're looking at this one right now. This is the one you're looking at right now. The one you should look at, if this is not a good one, the one you should look at after is you replace this one with two, right, which is here. That's the next greatest, right? Do you
Let me
agree?
think. It's one. Oh, okay. Yeah, I get it now.
And what would be the next
Yeah,
greatest after
okay.
that?
Yeah, okay. I get it now. So what you're saying is this first window, the sum is only one. But if I slide it over, the sum will be jump to 4 already, which is I'm jumping ahead of myself too much.
Exactly.
Um, but how can I increase one at a time though? The smallest. Okay, okay. Well, let's say okay. I'm thinking about binary search. So if I have like a three indexes, so so for example at this stage, right? So I have only three numbers. Let's say a negative 1, 0, and 1. What I need is six, right? So I'm gonna do a binary search on the rest of the numbers to search for six. If I cannot search it, if I cannot find a six, I'm gonna yeah. So what I'm gonna do? That's good. That's a good question for myself then. Um,
Wait, so how would you use binary search?
well, the thing is, I have these three numbers, right? So I know the current sum is gonna be zero, right?
Right.
And then the number I need is six, right? Because because now I'm at zero, so I need another number which is zero to make it up to six. So I'm gonna search for the rest of the array, which is this guy over here,
Okay.
and to see I can find six or not, right? The answer is no, I cannot. But the thing is, how can I know the next combination for these three smaller numbers? So that's another question for myself, right?
Yeah. I mean, I don't think it's necessarily necessary to go ahead and look for it. You just iterate. The key to the problem is finding like an intelligent way to iterate through the array. Like the solution isn't recursive. It doesn't actually involve binary search. It just involves you know that you're using n log n, which I think it's good that you thought of binary search because it's sorted. Like you want to take advantage of the fact that it's sorted. And we obviously, what do you think the brute force solution would be? I just before I
Yeah.
say what I say.
Okay. Yeah. The brute force solution will be like what we discussed. Will be have the first four numbers, which is this one over here, negative 1, 0, and 1.
Hmm.
And in this case, we will be at one, and then we search for the next smaller component. Well, the next one. Come back to our original discussion. So how can I know the next smallest combination though?
Even if, let's say, it's unsorted, right? How do you, if you have, let's say it was 2 instead of 4, right? You're given, let's say it's 2 sum, right? How do you brute force 2 sum? You just iterate, it's n squared, right?
yeah,
Even if it's unsorted, it's just n squared. If for the 3 sum, you have 3 pointers and you find all the possible combinations, it's n cubed, right? So for this one, it would
mm,
be n to the power of 4,
yeah,
right? So the fact that you're sorting it n log n at the beginning as like an overhead cost, because of the fact that it's sorted, you hope to find something that is more efficient than n to the power of 4, right?
correct. Yeah,
So um, I would say think about 2 sum and think about 3 sum. Like in 2 sum, you have 2 pointers, right? Let's say this is the array. You have I, j, and then you move them around in such a way that you find the answer faster. And then in 3 sum, it's the same. It's a similar idea. You have 3 pointers, right? You have 3 pointers, and you move them around in such a way that you're covering all the ground in an increasing fashion, right? So this is the same idea. You're just like there's four. There's four things that are moving.
okay, okay, 4 pointers. Very interesting. Um,
Like okay, I think this is this. Let's just look at. Let's consider that we have um, some I here, right? Or like let's just forget about the points for a second, right? If we this is the smallest combination. This is the smallest combination. Do we agree?
yeah,
And this is the largest combination.
yeah,
This is the if we this is the if we were to take 3 numbers, right? This is the smallest combination of 3 numbers, which means that the smallest combination of 4 numbers is just adding this, right? And if we want to
mm-hmm,
go like to like the next smallest, we know that everything that is um, past this one is going to be greater than it because it's sorted. So it follows that if we keep everything the same and we just move this here, that's the next smallest. And then if we, again, everything that is everything that is less than 2 is going to be smaller. So keeping everything the same, we move from looking at 2 to this 2, and that's guaranteed to be the next smallest or equal, right? We move that to 3, and that's the next smallest, right? So on and so on. And by the time we get to 5, hopefully we found it. But if not, what do you think we would need? What would be the next smallest? What do you think?
yeah. Okay, I can get what you're saying. So basically, we move this number around because the first one we just search this number, and then we find a replacement, right, for the in the rest. And then if we hit until this point, maybe we can go to the second smallest one, which is this number over here, and then we find a replacement for that, right?
Replacing which one? Sorry.
So I'm not sure if I'm following. So let's say the smallest number right here, it's gonna be looks like something like this, right?
Mm-hmm.
-1, 0, and 1, 1. So we can first thing we can find replacement for this one, right? As you said. So the next bigger number it will be 2. 2 is bigger
Right.
than 1, right? and then we
Yeah.
can check that, which is still small, and then we can check 2 again, and then find a 3, 5,
Right.
etc., and then find a
Exactly.
replacement. And when we
Exactly.
hit to the last number, which is 5, which looks like something like this,
Mm-hmm.
and then let's say if that's still not big enough, you can work on the second number from the right. Because we
Yeah.
work on this number, and then now we work on that number.
Yeah. Yeah. I mean, that's definitely one way to do it. Yeah. And then if you want to be even more efficient about it, um, you could have. Okay, so let's say we know I is here, we know J is here, right? Let's just call them I and J. These like are fixed for now. Let's call this L, right? And then I guess we can call it R, right? These are the 4 pointers that I was referring to earlier. Um, you're suggesting that we move R, right? And we keep I, J, L the
Yep.
same, and then we check everything. We check the sum each time, right?
Mm-hmm.
That could work. What do you think another way to do it is potentially? It,
Yeah, it's not
taking
very
a
efficient,
take,
unfortunately.
it's not efficient, but let's forget about binary search because it's actually supposed to be linear. I don't think that. I think what you just said makes sense, but I'm trying to steer you in the direction of the solution which is provided here. I think both work. But let's say that we have. By the way, I'm saying a lot because when I saw this problem, I had never done foursome, and unfortunately, it's one of those problems where unless you've seen this before, it's like extremely hard to like figure it out. It's just one of those things. Even the hints don't give me much to work with here. That's why
Okay.
um, I'm just gonna. All I'm gonna say is, let's say that we have R here at the very end, and we have L here. What do you think a good way to move the pointers is, so that we um, check the combinations?
Okay. So you are proposing like have the I and J fixed at first, and then just
Mm-hmm.
moving along, moving around this L and R, right?
Yes.
And let me think. So okay. Let's say if I still -1, and okay, now okay, I have some sort of like clear sum, which is -1 plus 0, which is -1, right? So what we need is 7. So the problem now becomes like a two-sum problem because we
Right.
have L and R, and then search for the sum of 7, which is 2 and 5.
Yes.
But how do we do two sums? Okay, okay, this is a bit easier than what it was before. Um, Let me think. Uh, yeah. So the way that I would do it is to have the left pointer. Right now is L is equal to 1. So what I'm gonna look for 6, which is not. I mean, for the right pointer, which is not in the rest of the array,
Mm-hmm.
right? Even the biggest one is 5. So in that case, I'm gonna advance the L pointer. Now becomes 2.
Mm-hmm.
So right now I'm gonna look for 5, and there. So we got it.
Wait. So how would you move the pointers in this situation? Like, where would could you like move the pointers around so I see what you like were referring to?
Yeah. Okay. So let me say it again. So I have L and J. So now I'm the current sum is -1. So I mean when the L pointer is in here,
Mm-hmm.
And what I need for the rest will be um, um, for 6, because when L is equal to 1, what I need is the rest will be the R will be 6, and then I look for 6, and I do not see 6, and then even the biggest one is 5, so I'm going to advance the L to here, right? And then in here, what I look for, the rest will be 5. Am I making sense?
But you have 3 pointers. You need four. You need four
Okay. Yeah. That's.
because you
But
you need
how does
four
how does the other pointer helps though?
because I'll push you in the direction I'm trying to get you to go. So we know that at the end of the day, whenever we find the combination that we want, we'll just append to some empty array all the values which are currently at these pointers, right? And until that's the case, we'll just keep looking. Um, so if this is a combination which we want, clearly it's not. Then we check, is this combination less than or greater, right? And depending on what that is, we can move L and R. We can move L or R pretty much. Think about how would
Mm-hmm.
you move, like if it's less than, what would you move?
Just less than, I'm gonna move the L to yeah, increase the L.
Right, exactly. And if it's greater than, you would want to move
Yeah.
R here because of the fact that it's sorted. It's guaranteed that this will be like at least less than or equal to what was before, right? And then that
Oh, I
saves
get
some
it
time.
now. Okay, I get it now. So okay. Uh, yeah, maybe I can. Yeah, maybe the first thing I can check is the smallest combination will be this one over here, 1+1, and the biggest one will be 5 and 5. Is that is not in that range? I can start to move this I and J pointers already. If
Pretty much,
if
yeah.
that
I mean,
if that number is if that the remainder is in that, I mean is in that range, I can start to move the L and R pointers.
yeah. I mean, I think it. You don't need necessarily to check that. It would save you some time, but I think like let's assume that like you're just like checking everything, right? Because it's just. I mean, it's just gonna. I think it's gonna complicate the code a little bit more if we start checking like the extremes first. Like let's just create a like simple iterative loop, like or various loops.
Okay, I got 5 minutes left. We'll see like what I can do with it. Probably I cannot finish it, but I will try my best. Okay. As we discussed, sort it first, and we need the I, J, L, R pointers, which will be 0. I mean, in the case where if the length is less than 5,
Mm-hmm.
less than 4, uh, we don't do the rest. Return empty list, right? So now we have the 4 pointers, 1, 2, 3, for 4
Mm-hmm.
pointers, and um, while I is less than, and also at the same time I is less than, at the end the I will be somewhere right here. That will be the most right position that right can be. So
Right.
that's gonna be less than the length of the array minus -1, -2, -3, -4. Yeah,
Mm-hmm.
-4.
Exactly.
And by the same logic, the J will be the one after it, -3. Okay.
Mm-hmm.
So now we have the 2 pointers set up. The I and J. Now let's work on the L and R. So we have the curve sum that we talked about right here,
Mm-hmm.
and the line 18, right? And I have 3 minutes left. So I got I plus I got J.
Hmm.
So I have the curve sum. Um, what do I do? So I have the L and R as well. And okay, this is what I'm gonna do. So while while the curve sum, as we discussed, right? While the curve sum is let me think. But I have the left and right pointer. Okay, so
Hmm.
the okay.
You have
Um,
access to you at this point. You know, um, yeah. I mean, you know the you can compare what the sum is to what you want, and then depending on whether it's, as we talked about, whether it's greater than. By the way, no stress. Like if it's, I think it's honestly, like, this is one of those questions, like, it's not like I said, it's unless you've seen it before, or like this exact approach to solving this kind of question, it's very, I couldn't solve it myself. Like, when I someone gave me this problem in prompt, I had to tell them, like, just tell me the answer. But anyway, I don't want you to feel stressed about like finishing it like in the next minute. So let me know if you
okay.
want to just talk about the approach. I'm happy to like just talk about it as well.
Well, I kind of pretty much as we discussed, and when you show me this one, or I've kind of know it already. So I have the left pointer, which
Right.
is J plus one, and then the right pointer will be on the other end,
Exactly.
and then I can start searching and narrow it down,
Hmm.
and yeah, the next step is gonna formalize as a code. But I want to discuss with time complexity. Yeah, obviously in a real interview I cannot solve this one.
Hmm.
Um, for time complexity, it's gonna be so I have the one for loop in here. Also, first one is gonna be over n log n already, but
Hmm.
for the sorting, and on top of that, we're also doing the four pointers. Um,
Right.
yeah, it looks like gonna be n square if I'm not mistaken.
It 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 would be
N cube.
exactly. It would be n cubed because ultimately the approach is going to be you check this right, and then you're going to move these pointers towards each other, and then if you find, I'm not saying this would be the exact way. Maybe L is moved all the way, whatever. Ultimately, they're going to overlap, and then when that happens, if you haven't found it, the next thing you want to do is move J forward and start all over again. You do the same thing. Sorry, start here, move them towards each other, and then if you don't find it, you keep moving J forward, and then if you move J towards the end, then you just move I forward and you bring J here, and you repeat the same thing, right? So that's the ultimately you would have three loops, making it M cubed.
Yeah, yeah.
I'm
Okay.
happy to paste in my code as well.
Yeah,
Let me know. Would you
I
want
can
me
take a
to,
look.
or okay?
Yeah, sure. Yeah, put at the bottom, and then I'm gonna review myself.
Okay, perfect. Yeah. So this was my solution after realizing how to do it. Another comments.
Wow. Okay.
Right. So you start off, like, you got the bounds right, and then you got this right as well, and at this point, pretty much you just advance them towards each other. Um, you make sure that they're in bounds, and then you know the sum because like you have four things that you're looking at, and then you just check, is
Yeah.
this less than what I want? If it is, we move L forward. If not, if it's greater, we move R forward, and if it's equal to, we found it, which means we just return where we are, like everything we have right now. And then these loops take care of the advancing, which I just showed you. If like all of this ends and we didn't find it, then we just return the empty array.
Yeah. Wow. I think I'm not sure this is the same question on Nico. I think that one maybe is returning all the possible combinations. I don't
Maybe.
remember exactly. Yeah. Anyway, this is brilliant.
Yeah, but like I said, if first of all, feedback. I think it's also great that you talked about your thought process throughout. You said at many different times, like I'm thinking X or I'm thinking this, like I'm thinking binary search. I think it's good. It shows the interviewer like, in fact, it gives the opportunity a chance. It gives the interviewer a chance to like either like maybe nod an approval, stuff like that. It's always good to just say exactly what you're thinking, which you did. Um, Also, in the same way which I did, you also had like a little example at the beginning with like just basically like how you would do it by hand, which really helps just like follow your thoughts. So that was really good. Um, Besides that, I mean, honestly, I don't want to hold it against you the fact that you weren't able to solve it because I I wasn't able to solve it. The interviewer who gave me this question also wasn't able to solve it. That's what they told
Wow.
me. So it's really one of those things where you know you've either seen this problem before, and then any problem that is similar to it in the future, you'll be like, oh, this is like a clever way to approach it. But yeah, it's one of those things where like unless you've seen it before, it's very um, I mean, it would. I would be very surprised if somebody was like, "Oh, like this is how obviously you have four pointers, you have the left and the right moving towards each other." Like, I would be very shocked. Um, but you've seen it now, which is good.
That makes me feel a little better than before.
Yeah, 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 honestly,
Thanks for that.
yeah.
Okay, so best of luck to your interview on Friday. So how many round of interview on that day?
Um, I believe it's one. It's very weird. I think it's
Only
just one.
one.
Yeah, they told me it's one. So maybe it's
Oh,
not the final one. Maybe I'm confused. But I told them, look, I have an offer deadline on October 31st. So let's just do it as soon as possible so that you can get a decision before the 31st.
oh, so you already have an offer already.
Yeah.
Okay.
Yeah. I
Wow,
got,
nice.
yeah.
Good for you. You're in really good position then.
Yeah. Yeah. I mean, like, I want, because it's a return offer. Like, I worked at Bloomberg, like software engineering like this past summer. So I would be happy to go back, but I also want to try something different. But yeah, it definitely helps because I just tell recruiters like, let's make it happen.
Excellent. Yeah, I've been using Bloomberg every day. I'm the Bloomberg user though. I'm not a software engineer.
Yeah.
So well, good for you. That you are so you were okay. So you work in as an intern or as a software engineer
Intern, yeah,
in
intern
Bloomberg.
Bloomberg. Yeah,
Okay.
I'm still a student. Yeah,
Oh yes, you're just still a student.
yeah, yeah,
Okay.
yeah. I'm still a student, so I'm just doing internships.
So Facebook is not your dream company, as you mentioned. So
Nah,
which one is your dream? Which one is your dream company right now?
Palantir,
Which one?
Palantir. That's the dream.
How to spell it? The name?
I'll put it on line 53.
Yeah. Okay, I never heard of this company before.
Yeah,
Probably.
it's really great.
Do they pay well? This one?
They pay very well. Yeah.
Okay. I was seen a guy from prom, and he went to Wish, and then he told me that Wish is even paying better than Google.
Really?
Um, yeah, and I look up on levels
Mm-hmm.
website, and then
Yeah.
Wish paying like for the entry level like a 200,000. So
How
Wish
much?
right now is 200,000.
Oh, really?
That's what I saw on levels.
Yeah. Isn't
Uh,
that the same as
yeah,
Google?
but um, I think they pay a little bit more than Google. That's what I was told. I don't
Oh,
know.
okay.
Yeah,
Interesting.
I actually interviewed with Google 2 months ago, but I didn't make it though. It
No.
was really hard. Yeah,
Yeah, it's always hard
I
with
was
Google.
told I was told to code up a an object which is a iterator, Python iterator,
Oh,
but I couldn't.
that's horrible. It's horrible.
Yeah, it was brutal. But it was on me though. I wasn't prepared enough like 2 months ago. That's why I keep coming back to a prompt.
Hmm.
Anyway, yeah.
Yeah.
Anyway, best of
Anyway,
luck.
man. Likewise,
Yeah, on
best of luck to
Friday.
you as well. Thank you, man. Thank you. Pleasure meeting you.
Hmm.
Take it
See you
easy.
next time.